In this session of CCNA series, I'll discuss about Cisco Wireless infrastructure connections and management access. A wireless network can consist of APs such as autonomous AP or lightweight access point. These lightweight access points are coupled with one or more wireless LAN controllers. These APs are connected to LAN side to pass traffic between the appropriate VLANs and wireless LANs. An autonomous AP is a standalone device. It maps each VLAN to a wireless LAN and BSS. It includes a single wired Ethernet interface which is configured as a trunk with a LAN switch. Through the trunk, each frame is tagged according to the VLAN number it came from, and then access point inherently marks those frames with the SSID of that wireless LAN. A lightweight access point also includes a single wired Ethernet interface and must be paired with a WLC. Wired VLANs that terminate at the WLC from wired network are mapped to wireless LAN on the AP site. Here multiple VLANs are being extended from the WLC to the access point through the LAN switch. The link between the WLC and the switch is configured as a trunk, and the link between the switch and the AP is configured as a access link. Traffic between the WLC and the access point is carried over the CAT-WAP tunnel. Next, let's look at how we can have management access connection on AP and WLC. Cisco APs can be managed through the console port on the AP. Once the IP is configured, you can also use Telnet or SSH to connect to CLI. Autonomous APs support browser-based management sessions via HTTP or HTTPS, whereas lightweight APs can be managed from a browser session to the WLC. Let's see how we can access a WLC. Connecting a Cisco wireless LAN controller to the network is not quite as straightforward as it looks, and it has several different types of connections. It can be managed through a web browser using HTTP or HTTPS protocol along with a management address. But before that, management IP address needs to be configured on its management interface. The web-based GUI provides an effective way to monitor, configure, and troubleshoot a wireless network. WLC can also be accessed through a SSH session. Both the web-based GUI and CLI requires management users to log in. And these users can be authenticated either locally or by using a AAA server using protocols such as Tokax plus or Radius. Cisco wireless controllers consist of ports and interfaces. These WLC ports are physical entity that is used for connections on the controller platform, such as to connect to its neighboring switch in the wired network. These physical ports scatter you to connect to an external wired or switched network. On WLC, you have four types of ports, starting with console port, which is used for initial configuration and troubleshooting functions. Then we have distribution system ports. It allows you to connect to a controller to the neighbor switch and serves as the data path between these two devices. It is used for all in-band traffic, which usually connects to a switch port in a 802.1q trunk mode. To get the most use out of all ports, you can configure them as a lag or link aggregation group such that they are bundled together to act as a one larger link. Then we have service port. The service port is used for out-of-band management of the controller. or system recovery and maintenance in the event of network failure. The port is assigned to a management VLAN so that you can access the controller via SSH or web browser to perform any configuration or maintenance. It is the only port that is active when the controller is in boot mode. The service port does not support 802.1q tagging, so you must configure the switch port on the other side in access mode. The fourth port we have is redundancy port. This port is used to connect to a peer controller for HA operation or high availability operation. Let's look at the WLC interfaces. A WLC interface is a logical connection on the WLC that maps SSID to a VLAN on the wired network. Those internal logical interfaces must be configured with an IP address, subnet mask, default gateway, and a DHCP server. Each interface is then assigned to a physical port and a VLAN ID. You can think of an interface as a layer 3 termination on a VLAN. So there are 5 types of interfaces available on the controller. Starting with dynamic interface. It is used to connect a VLAN to a wireless LAN. Dynamic interfaces are created by the network administrator and are for carrying the wireless client data traffic into different VLANs. The WLC supports up to 512 dynamic interfaces, but each dynamic interface must be assigned to a unique IP subnet and a VLAN and acts as a DHCP relay for wireless clients. Then we have management interface. The management interface is the default interface for in-band management of the WLC. Used for traffic such as radius user authentication, WLC to WLC communication, web-based and SSH sessions, and also SNMP, NTP, syslog, and so on. It is also used to terminate CAP-WAP tunnels between the controller and its APs. It handles the layer 2 communication between the controller and any access points. Then we have virtual interface. This interface supports mobility management, DHCP relay, and embedded layer 3 security such as guest web authentication and VPN termination. It must be configured with an unassigned and unused gateway IP address. Then we have redundant management interface. This interface includes the management IP address of redundant WLC that is part of high availability pair of controllers. The active WLC uses this management interface address while the standby WLC uses the redundancy management address. The active WLC uses the management interface address while the standby WLC uses this redundancy management address. Then we have service port interface. This interface is bound to the service port and is used for out-of-band management.